Hi, thanks so much for listening to my talk about Suon Laulu, or Song of the Swamp. This is a visual score that I've made in collaboration with composer Hannah Selin and programmer Brian Gibbons, and it was performed this past October by the Tuira Chamber Choir in Oulu, Finland. I am based in Denver. I am an assistant professor of art at Metropolitan State University of Denver, and I've been working with scientists and restoration ecologists for the past decade or so, trying to find ways to materialize their data and use art to kind of reveal what's happening hidden away underground or at a time scale that's so different from ours that it's a little bit hard to understand. And in this case, the material I'm most interested in is breath and thinking about how the soil in these peatlands is respirating just like we are. So this whole project began as a Fulbright fellowship, and I was working at Luke, which is the Finnish nickname for the Natural Resources Institute. I was the only artist embedded in this science organization. And this, by the way, is what it looks like if you try to bring your art studio for a year on a plane. If you're not familiar with Oulu, this is where it is, about halfway up the coast of Finland and 3 hours below the Arctic Circle. So just to set the scene, in the summer, you can harvest fresh blueberries and mushrooms, eat dinner on a riverboat. In the winter, things change a little bit. And this was our local floating sauna. It was a boat on the frozen river. And when you heat it up enough in the sauna, you could go through a hole in the ice and take a dip in the river. But I was most interested in how plants survived these extreme conditions, specifically this plant, sphagnum moss, which engineers peatland. And you can see a conserved peatland on the right here. So only the top part, this capitulum of the plant, is alive. And then all of the stuff that makes peatland the way it is happens a little lower down. So the part of the stem that's no longer growing coils and forms this mat, which can create an artificial water table. And if you zoom in even further, these are the hyaline cells, and they're kind of sponge-like, so the plant can absorb 20 times its weight in water. And what this means is if you're a small shrub or a tree trying to grow in the peatland, you can actually, as you grow heavier, drown yourself with your own weight. And this also makes this waterlogged acidic environment where nutrients can't really break down. It's anaerobic, and so you have preservation of things like the pollen record, for example. But here's the issue with peatland. We like to use it for fuel, and Finland has a really efficient system of using it for electricity and heating. But here's what you see when the peatland has been drained and kind of scraped away, and it's not possible, even though this is a biofuel, to really regrow a peatland within a series of lifetimes that we even know of. So we're left with a novel ecosystem. And so my collaborators in Finland had been studying what's happening in these test plots for about a decade, testing out different amendments to the soil. And you can see this sort of scraped away, like acidic desert that's left behind. And then they were looking at what could make this land productive again, but in a different way. We got to fly a drone at work to see all of this, which was pretty fun. And we also had some access to some interesting tools. This is a hyperspectral camera. So instead of a typical camera giving us a 2D image, in this case, for every pixel, we also have a z-axis of wavelengths that we can't see with the naked eye. So for example, this is one type of graph that we could get from this camera. And we only have this small fraction of wavelengths we can see, but all of this other information about cell structure, water content, things that we can find out actually about the soil. And I started thinking, if we can't see these wavelengths, what if we could hear them? This was a soil core sample from one of our sites. And here it is in the analysis software. Very entertaining to learn a new software, kind of half in English and half in Finnish. And if you select one pixel, you'll get a graph like this. So what I did is I started plotting these graphs onto a music staff. And I'm thinking about this tradition of playing with music notation as code and playing with line as something that can be performed, and thinking about the soil as composer and myself as arranger. And so I'm kind of collaborating with this soil, and thinking about how we can perform data instead of kind of trying to collect it and analyze it, kind of hear it and experience it and then let it go. So this is the first draft that I came up with. And so we have tempo and volume that are being controlled by water temperature and water level. Then we have the top staff is the fertilized core sample, which has been treated with peat ash, which is the industrial byproduct from burning peat for fuel. And it's really basic in pH, so it helps neutralize the acidity of the soil that's been left behind. And then we have the control sample in the bottom staff. And so what I was expecting to find was that the fertilized sample would have a higher water content, and so a bigger dip in that graph. And so a more kind of separated major bright sounding chord progression. And then that control sample would have less water content and would have less of a dip in that graph. And so a more dissonant sounding tone. So next I sent this to Hannah Selin, and you can see her there and a few of her iterations as she was processing this kind of unconventional music notation into something for the New Music October Festival in Oulu in 2023. And this is just some of the sheet music that she produced. And you can see there some of the original lines that are meant to be performed as this sort of breathy whistling. And there also are breath marks, those sort of comma looking things above that staff. Those are areas of no reflectance. And so that's aeration in the soil. And we're meant to kind of experience that as a breathing in from this chorale. This score is about 10 pages long, and the piece is about 10 minutes long, and it's representing about, we think, 160 years of peatland soil development. This is the choir that performed it, the Tuira Chamber Choir. And you can see they've done some more experimental work in collaboration with Finnish Nature before. And I'll just talk briefly about the video that accompanies this choral piece. It was made with collaborator Brian Givens using these two images. The image on the left is the only one you see, and it's made with a stereo microscope looking at one stem of sphagnum moss. But what's happening in the background is all of the pixels of that left-hand image are being rearranged using what you see on the right, which is the false color Resonon analysis software image from the hyperspectral camera. And this is a tiny portion of the code that Brian wrote using processing visual coding language. And here are a couple still images from the video. So we start off with this sort of scattered, almost reminds me of the pollen that's sort of scattered and preserved within this soil image that you see on the left. And then as the choral piece progresses, it slowly resolves into this recognizable stem of sphagnum moss that you see on the right. If you're interested in listening to the full piece, there is a QR code that'll take you there. And I'll just end here with a few images of the peatland site that we were working with after the restoration study was complete. And if you'd like to see any more of my work, some of it has to do with peat, some has to do with soil and other plants. I'll leave the link there for you. And thank you so much for your time. Bye.